Hi and welcome back to maths class. So what we're doing today is we're going to look at using the product rule. So before we do that, let's just remember what the product rule is and what it's for. The product rule is a rule that I use when I want to differentiate a function like this, which is e to the power of x times sine of x. So this is a function, e to the x, and this is a function, sine x. When I multiply them together, I can make a new function, but I don't know how to differentiate it. So one of the things that you need to remember is we can't just differentiate e to the x and differentiate sine x and then just multiply them together. It simply doesn't work. So we have the product rule, which we looked at where it comes from in the previous video. What I have is the derivative of that product function is going to be the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. In dy dx notation, this looks like if y is u times v, then dy dx is u times dv dx plus v times du dx. So these are two different versions of the product rule, and here's my first worked example. I'm going to differentiate y equals 3x squared plus 5 times 7x cubed minus 11. Now I could expand this one out, but I'm going to try and use the product rule just to see whether that's easy or difficult for me. So the first thing I'm going to do is define u and v. U is going to be my first function, 3x squared plus 5, and v is going to be my second function, 7x cubed minus 11. So I need to differentiate both of those with respect to x, because remember in this rule I need dv dx and I need du dx. So du dx is 6x and dv dx is 21x squared. Okay, now I can apply my product rule. So let's remember what it is. Let's make some room here. Dy dx is going to be u times dv dx, that's u, and that's dv dx, plus v times du dx, that's v, and that's du dx. So I'm sort of multiplying these across. So dy dx is going to be u, that's the first function, times the derivative of the second function, plus v, that's the second function, times the derivative of the first function. Okay, now this looks to me like if I expand it out, that's going to give me a quartic term, that's going to give me a quartic term, so it looks like I'll be able to expand and simplify. So let's do that. 3 times 21, that's going to give me 63x to the power of 4 plus 21 times 5, that's going to be 105x squared plus 7 by 6, that's 42x to the power of 4 minus 66x. Okay, 63 plus 42, that's 105x to the power of 4 plus 105x squared minus 66x. Now it looks like I could factorize that, but there's no reason to. I've expanded it as much as I can, so I'm going to leave it as it is. All right, let's do another example. I'm going to differentiate h of x equals sine x times cos of 2x. So I need to differentiate sine x and I need to differentiate cos x. So first of all, I'm going to write let f of x equal sine x and let g of x equal cosine of 2x. And then I'm going to differentiate each one. F dash of x, the derivative of sine x, of course, is cosine x. And g dash of x, the derivative of cosine x is negative sine x. With the 2 out the front, it's going to be negative 2 sine of 2x. And now I need h dash of x. It's going to be f of x times g dash and g of x times f dash. So it's going to be sine x times negative 2 sine of 2x plus cos of 2x times cos of x. I can't really simplify this, but I want to rewrite this line as negative 2 sine x times sine of 2x plus cos x times cos of 2x. And I'm done. My last example is differentiate y equals log base e of 3x over x cubed. Now this doesn't look like a product. It looks like a quotient because I'm dividing x cubed. But what I'm going to do in order to use the product rule, which is when we see the quotient rule, you'll see it's more complicated. The product rule is always a little bit simpler. So I'm going to rewrite this as log base e of 3x times x to the power of negative 3. So now I've got two functions multiplied together. I can use the product rule. Now this time I'm going to do it the shortcut way. I'm not going to write out all my working. dy dx is going to be the first function times the derivative of the second plus the second function times the derivative of the first. So the first function, log base e of 3x, times the derivative of the second function. So let's take the derivative of this. I'm going to have negative 3x, and I subtract 1 from the power, so I get to the power of negative 4. Now I add the second function, leave it as it is, x to the power of negative 3, times the derivative of log base e of 3x, the derivative of the first. Do you remember this one, guys? It's going to be 1 over x. Okay, in fact, it's 3 over 3x, and the 3's will cancel, giving me 1 over x. Okay, let's expand and simplify, and I'm going to rewrite all my negative powers as positive powers. I'll take this negative 3 out the front here, log base e of 3x, and it's going to be over x to the power of 4. And here, this is x to the power of negative 3. That's the same as 1 over x cubed. So it's going to be plus 1 over x to the power of 4, which I can rewrite as 1 minus 3 log base e of 3x over x to the power. Whoops. Sorry, guys. You couldn't see that. Over x to the power of 4. And we're done.